In this example, we'll be reviewing simplifying a rational expression. We don't really have any addition or subtraction, and we're focusing mainly on isolating like pairs of terms in order to simplify. If I look at the example I have here of 12x cubed y squared divided by 9x to the 4 y, I can see that I've got some like groups that match up quite nicely. If I divide these up into three groups, it would look like this. I would have the 12 and the 9 being part of one pair, the x to the 3 and the x to the 4 being part of another, and the y squared and the y being part of a third. So what that allows me to do is treat these as three individual problems and simplify them individually that way. So if I take 12 over 9, I can think of that as a fraction, both top and bottom divisible by 3. So dividing 12 by 3 and 9 by 3, I get a 4 on the top, and I get a 3 on the bottom. So an equivalent fraction to 12 over 9 will be 4 over 3. The same thing would be true about the x cubed and the x to the 4. Recall that x to the cubed is just another way of expressing 3x's being multiplied together. And x to the 4 is just a way of expressing 4x's being multiplied together. So if we want to view this as pairs matching up, then I can see that the 3x's on the top would cancel with 3x's on the bottom, leaving me with a single x in the bottom of my expression here. So this is the second part of this done. So we've simplified this, we've simplified this. Now we'd like to look at y squared over y. The same idea, y squared represents y times y with a single y in the bottom. So we can see that those two expressions, or those two y's on the top, cancel with one of the y's on the bottom, which leaves me with a single y on the top here. So this would be the simplified expression of the original I started with. Now, what I would also need to do in order to make sure that these are equivalent would be to determine the MPVs and make sure those are stated with my simplified expression. So I need to focus on the 9x to the 4y. Now, since this is a monomial with the variables just with a coefficient, then if x was 0 or y was 0, then I would not be able to evaluate this expression. So I simply need to state that here, that the non-permissible values are x equals 0 and y equals 0. So when I go to state my final problem here, I would have 4y divided by 3x, and I would then state that x can't be 0 and y can't be 0.